Good morning, friends. Now we are discussing introduction to fluid dynamics. So that is module number 3 of the subject fluid mechanics. What is fluid dynamics? So it is, in simple words, we can say that it is the study of fluid motion with the forces responsible for the fluid flow. So in physics and engineering, we'll consider the fluid dynamics as the discipline of fluid mechanics. So that is describing the fluid flow. So the fluids considered are both liquids and gases. So the fluid dynamics is having the sub branches like aerodynamics, that is the study of air and other gases in motion. The other one is hydrodynamics, that is study of liquids in motion. So it is based on the analysis of fluid dynamics is based on Newton's second law of motion, so which is related to acceleration. So according to Newton's second law of motion, we say that the net force acting on the fluid element in x direction, so that is the force in the direction of x on a fluid element is equal to the product of the mass of the fluid element, so that is m, multiplied by the acceleration of the fluid in the x direction. So fx is equal to m into ax. That mathematically we say Newton's second law of motion, F is equal to ma. So considering the flow of the fluid in x direction, so the net force acting on the fluid element in the direction of x is given by the product of mass of the fluid element m into acceleration ax in the x direction. So in the fluid flow, we have to consider the following forces: Fg, that is the gravity force; Fp, that is the pressure force; Fv, viscosity force; Ft, turbulence force; and Fc, compressibility force. Thus, in the equation, what we have, Fx is equal to m into ax. So we have the net force Fx is equal to Fgx plus Fpx plus Fvx plus Ftx plus Fcx. So considering all these forces in the direction of x. So if the force due to compressibility, that is Fc, that is if you consider Fc as negligible, so that is the compressibility force acting on the fluid is very small, then ignoring this Fcx, we have the other four forces. So this equation of motion is called Reynolds equation of motion. When Ft, that is turbulence force, is negligible, so ignoring this Ft, so considering the other three forces, so the equation of motion will be called as Navier-Stokes equation. So we are considering gravitational force, pressure force, and viscosity force. So if the flow is considered to be the ideal fluid, then the viscous force, viscosity force Fv is also 0. For ideal fluids, there is no viscosity. Then the resulting equation of motion, that is the sum of gravitational force plus pressure force. We have left out with only the other two forces, gravity force and pressure force. Such equation is called Euler's equation of motion. So we have Euler's equation of motion. The Bernoulli's equation of motion is based on Euler's equation of motion. So before deriving the Euler's equation of motion, the assumptions made in the derivation of Euler's equation is that the fluid is considered as ideal fluid. So viscosity is 0. the flow is incompressible. That is the flow, we cannot compress the flow. Flow is steady and flow is irrotational. So these four assumptions are made. So Bernoulli's equation is derived from Euler's equation of motion. So these are the three equipments. We are very much familiar in fluid mechanics. So Venturi meter, orifice meter and pitot tube. So these three equipments are working based on Bernoulli's equation of motion. So these three equipments are used to measure the rate of flow. What is Venturi meter? So it is a device used for measuring the flow rate of the fluid through a pipe. So Venturi meter consists of three parts: a short converging part, throat and a diverging part. So that is, there is gradual change in the diameter. So from the diameter D1, so we have gradual decrease in the diameter of the pipe. So that is short converging part. Then so the decreased diameter continues for a small length. So that is called as throat. Again the pipe diameter starts increasing. So that is diverging part. So because of this gradual change in the diameter of the pipe, so there will be a pressure drop when the fluid is flowing in the pipe where the Venturi meter is fitted. Then we have orifice meter. So it is a plate. So that is used to measure the rate of flow. So Venturi meter, orifice meter and pitot tube, all are the devices used to measure the rate of flow. The difference is that Venturi meter is having the gradual decrease in the diameter of the pipe, whereas in orifice meter there is a sudden decrease in the diameter of the pipe. So we have a flat circular plate which is fitted in some part of the pipe in which the fluid is flowing. This circular plate is having a circular sharp edged hole. So this hole is called as the orifice. So there is sudden decrease in the diameter of the flow. So from a diameter D1, so there is all of a sudden there is a decrease in the diameter. So the flow now starts flowing through this hole called as the orifice. So that is concentric with the pipe. That means this circular hole is the center of the circular pipe is exactly concentrated with the center of the pipe. So compared to Venturi meter, orifice meter is cheaper. Then we have pitot tube. So it is a small device used for measuring the flow velocity at any point in a pipe or a channel in which the fluid is flowing. So pitot tube is used to measure the flow velocity at any point in a pipe or channel.